is that you can work with radicals by converting them back and forth from and into rational powers. And so here's what the conversion looks like. Again, when you're looking, you have your index here, this power m, and this base a. When you convert this into a rational power, the base stays the same and the power stays the same. The only thing that you need to change is the index becomes the denominator of a rational power. Okay, so the nth root of a to the m is equivalent to a to the power of m over n. Right, and so this is one of the things when you are using your TI-89s, and when the time comes, obviously you're not really using them in this class that much, but when you do any kind of q or any kind of root other than a square root on the TI-89, one of the ways that you can do it, or are expected to do it, is to rewrite it as a rational power. So the cube root of 25 on the TI-89, you would write 25 to the power of 1 over the index 3. So 25 to the 1/3 is equivalent to the cube root of 25. Now, here's what you're being asked to do with regard to these values. Anytime you recognize a perfect power, you should think of it in its simplified base. Okay, so even though 25 to the 1/3 is another way to write, or is the rational power form of this expression, 25 is a perfect square. So the preference is to think of this first as the cube root of 5 squared, and then as the power, or as the rational power 5 to the power of 2 divided by the index of 3. So this would be the sort of preferred method, although both of these are exactly the same. This and this are representing the exact same thing. Even if you have powers or radicals that are in the denominator, we can express them using negative powers. So here we would take our base x. The power of 2 is in the denominator, so we would write this as a negative 2. And then the index is a 3, so we would write that as the rational power. So x to the negative 2/3 is how you would express this. Right. So what I want you to do is see if you can answer the 3 questions on the side here. Can you rewrite each of these in their rational power form? Right, so each of these, what you're going to do is start with your base, same base. Then take the power, same power, and then divide by the index. So in this case, the index is a 4. So 7 to the 5/4 is how you would express this first. Next, you take your base, 3 to the power of 7, divide by the index. A square root has an unwritten index of 2. So there's your rational power. And then finally, the last one, take your base, 11. Now, if there's no power written, you just express it as the unwritten 1, divide by your index, which is the 3. So the cube root of 11 is expressed as 11 to the 1/3 power. All right, questions on that process? And let's work in the reverse direction. Now, you can also use this same relationship to convert a rational power into a radical, and it's the same idea. You have your base, you have your power, you have your index. So know how that is represented. We have, again, what I would usually do here is start with the index. So I'd put my nth root of my base a to the power m. Okay, and so that would be your conversion. And so if we look at these 2 examples here, write my radical form, so write my root, plug in my index first, the 4, then my base a, then the power 3. Okay, same thing here, take my radical, plug in my index, 5, my base 3, to the negative 2, now the negative puts that in the denominator, so I'm going to write it as a fraction, the power then changes to the positive. And so that would be my expression here, written in that radical form. All right, so same idea. Try that with these 3 examples and see if you can, if you have any issues converting those into their radical forms. All right, so again, when you're looking at this, we have our radical, I'll zoom in so it's a little bit easier to see. I take my index, which is a 5, so that's the 5th root of 7 to the 1st. I just leave it written as that. Next, I write my radical, take my square root, so I leave it as an unwritten 2. Do not enter the 2 in. My Open Math system will not recognize 2 written in the index form. Just leave it unwritten. I do have my base of 10 and my power 7. You don't need to simplify the radical. We're simply converting forms. And then finally, the last one here, set up my radical. My index is a 5, so 5th root. My base 3 to the power 2. So most students don't have too much of an issue with this. The issue comes on this next slide, are the ones that are a little more challenging as far as trying to keep track of what's your base, what's your power, what's your index. Okay, so I want you to try, let's do the ones on the left here first. So try these two. See if you can identify the other forms. So from the first one, convert it to a rational power. The second one, convert it to a radical. See if you can follow the rules that we talked about and write those alternate forms. You want to be really careful. Think about the grouping symbols that it would take to express what you're writing. And I'll give you a couple options here for this first one. So notice that the base of your radical is not 11x and then to the power of 7, right? Because the 11 is nothing connected to that power 7. So you can't think of that as being the entire quantity 11x taken to the power of 7. So what you would need to do is you would need to think of this whole grouped set of factors, 11x to the 7th. That is your base. And if that's the base, it's taken to this unwritten power of 1 divided by our index of 11. So this right here would be one way that you would express that as a rational power. Now the other way would be to apply that radical to each individual factor inside the radical. So the other way to think of this would be as the 11th root of 11 times the 11th root of x to the 7th. And if you thought of it this way and converted it, you would have 11 to the 1 over 11, and then you would have x to the 7 over 11. So this would also be a possible way to write that, where you take each of the individual base factors and apply the power directly to it. Now notice in the bottom though, now there are grouping symbols around that entire 10x. So here when you convert it into the radical form, we start with our radical. I suggest that you begin with your index of 7, take the base of 10x. You do need grouping symbols around this. If you don't put the grouping symbols, and then you put this power of 7, okay, that is the correct answer. But if you didn't put the grouping symbols and you put 10x to the 7th, that is not the same. These are not the same values. Okay, so you do need the grouping symbols around the base. All right, so there's some subtleties here. It might take you a few attempts, try similar questions, or ask me questions if it's not working out for you, if you're still you're struggling with that. Let's do one more pair of examples here on the right side. Okay, see if you can do the same thing. Convert the top part into a rational power, convert the bottom part into its radical form, please. So here again, it's keeping track of what is the base of your power, whether it's a rational power or just a normal power. So when you look at this right here, the 10 out front is its own thing. Okay, so we'll leave the 10 as it is. When we write our base is the x to the power of 5 divided by our index, which is 19. And so notice this representation does not put the 10 as part of the base, right? There's no grouping symbols around the whole 10x because that power of 5/19 does not apply to the base 10. All right, and then the final example. Here we're putting it into a radical form. So again, when we set up, we see rational power here. Convert to radical, we have an 8 for the index. The base, since there is no grouping symbol here, the base is only what's exact or right immediately to the side of the power. So x is the only base taken to the power of 3. So what happens to the 8 that's out front? Well, the 8 out front stays out front. Okay? And so this would be your radical form when you convert. All right. So the first half of the questions will be just doing these, converting back and forth between the two forms. Okay, the back half is the one that's a little bit more similar to what you might see on an ACT, and that is to simplify rational powers without using a calculator. You should be able to do this with no calculator at all. So more than likely, there's no calculators on the next couple quizzes, because there's nothing that you need a calculator for, and you need to be able to do these by hand. Right, so notice the way that these are kind of set up. What you're looking to do is, again, I will always try to apply the negative power first, so as I go through the list of kind of what I would suggest, I'm going to start by applying any negative powers. And then I'm going to apply the root part of the denominator. And I'll show what I mean by that. All right. So I'm going to show you two different ways that you can do this. Okay, so the first one is apply the negative power first. So the negative power is going to invert my fraction and change the sign to positive. So that's my first step. Now my second step here is to do one of two things. Okay? For most of these, in my opinion, it's easier to think about the rational power by applying the root part of that power. Okay? And so what that means is the index here, this power of 1/3, is actually the third root, right? The cube root of that. So if you apply that to both parts of this, what's the cube root of 27? 3. And what's the cube root of 8? 2. What you can do by applying that is you can now reduce it to smaller and easier to use numbers. And now the last step would be to apply the power part. Of that rational power, because now that's all that's left, right? And so now you have 3 squared, which is 9, over 2 squared, which is 4. Okay, and so that's the way I would, that's kind of the way that I would recommend this to begin with. Okay, there is another way that you can think about this. Okay, and so let me talk about that, so that, and then you can choose whatever you want. But usually I will, like the examples that I go through will tend to be this process. Okay, so here's the alternate way to think of this. What you could do, if you would like to, is I'd still suggest you apply the negative powers first. So I'm going to resolve this. I'm first going to apply the negative power. The next thing is, what you can do is you can express each number in its exponential form. Okay, so here the option is to express each number as an exponent. Okay, so here's what happens if you do that. So 27 you can express as 3 cubed, and 8 you can express as 2 cubed. So now if you did this, you can then just apply the properties of the powers. Okay, so here when you take this power to a power, that 2/3 is going to apply to each of the numerator and the denominator. So a power to a power you multiply, so you get base 3 to the 3 times 2/3, base 2 cubed to the 2/3. And when you take a power to a power, you multiply, so those multiply here, and you get 3 squared over 2 squared, which is your same answer, 9 over 4. Okay, so you can either apply it as a root, or you can rewrite the exponents and then just apply your properties directly. All right, I want you to try the other two problems in the top. So see if you can answer these two questions here. All right, so if I'm looking at this, I apply my negative power first, so 1 over 256 to the 3/4. Right, now I can apply my fourth root. Even though I don't know what the fourth root of 265 is, I have a good idea. It's an even number, right? So you're thinking either 2, well, 2 to the 4th is, if you looked at 2 to the 4th, is like saying 2 squared squared, so 4 squared, which is 16, so that's not it. Okay? What if you took 16 and you squared it? That would be 256. So 256 is 4 to the 4th. Okay? And so when you look at that process, what you can do is if you apply your fourth root to 256, you get 1 over 4. The cube, the power of 3 is still involved. We haven't applied it yet. And so now we cube both the 1 and we cube the 4, and that gives us our answer, 1 over 64 for this. Okay. Same idea here in the next one. It's the 1,000 to the 1/3. Apply the power of 1/3, which is the cube root. And again, the cube root of 1,000 is just a 10, so this one's pretty direct to get that answer. All right, try these three problems on the bottom very quickly. Okay, these are, again, types of questions that you should be able to work through relatively quickly as you're doing this. So again, each of these is a slight variation with like how you're being asked to manipulate signs or bases. But use the denominator, the index part of the rational power to help determine how you can simplify. So again, what I would do, the negative stays outside. I'm going to use apply the negative power first. I'm going to flip my base. Becomes to the power of 2/3. I take the cube root now of 8, which is 2. And then I'm going to take that and square it, which is 4, and then take the opposite of that. So I get -4 as my answer. Again, the negative becomes a multiplying part, the opposite of. Next example, again, apply my negative power. This time the negative is part of the base, so I get -27 to the power of 4/3. I'm then going to apply my cube root. The cube root of -27 is -3. -3 to the 4th is kind of like saying -3 squared squared. And so I can take this 9 squared is, or -3 squared is +9, 9 squared is 81. It does make sense. The negative sign is gone because you took it to an even power. Finally, this last example, apply the negative first. So I'm going to move my 125 up to the numerator, and it's to the power of 2/3. Apply the cube root. Cube root of 25 is 5. 5 squared is 25. And so again, if you work through and use the root part first, that will usually be the easiest thing to do. Now, it's not always going to be the case. You'll see here on these next couple slides that there are instances where you might want to do the power part first, but it's all completely up to you. It'll work out regardless of whether you do the power or the index, or the power or the denominator, the radical first. Okay, so I want you to try these last two questions that are a little bit more on the challenging side, okay, and see if you can evaluate these without using a calculator. Okay, so here would be some of the other values. Again, if you don't have access to a calculator, you can either create these by just multiplying it out, what you already know. So again, 2 to the 4th is 2 squared squared. So 2 squared is 4, 4 squared is 16. 3 to the 4th is 3 squared squared. So 3 squared is 9, 9 squared is 81. Now 4 squared squared is 16 squared. Again, not the easiest thing, but you could just write it out by hand if you needed to calculate it, and if you don't remember, but that would be 256. And 5 to the 4th, same thing. 5 squared squared, so 25 squared, or you can write that out and multiply it by hand, but it's 625. Anything to the power of 5, really the only two that you would even need to consider would be base 2 and base 3. And those ones you can just multiply out again if you need to. So if you build 16 times 1 more 2, gives you 32. And for 3 to the 5th, if you take 81 times 1 more 3, you can write that out, and you would get 243 for your answers there. All right, so if I'm simplifying this first one, the negative is part of the base, so that stays in. My negative sign is going to flip my base and change the power to positive. And now I'm going to apply the index part of this, the root part of the rational power. So I do have a negative. The 5th root is going to keep that negative. So if I take the 5th root, I'm just going to kind of group this as a 32. So negative 32, I see that the 5th root of that is base 2. So a negative 2. And then the 5th root of 243 is 3. And that's all to the power of 4, right? I applied the denominator part of that rational power first. And now if I take negative 2 to the 4th, the negative sign is going to be eliminated here, but negative 2 to the 4th is 16 over 3 to the 4th, which is 81. So that would be your first answer. And then in the second problem, once again, I would apply the negative power first. So that moves the square root of 243 up and then to the 2/5. Now here is that example where I normally would take my denominator and apply the 5th root, which I still could do. Okay, but to me, I can get rid of that radical right away by applying the square. So this is the case where I would go ahead, apply the square first, get rid of my radical, so the square and the square root cancel, and I'm left with the 5th root of 243, and I see that's right here, equal to 3. And so that would be my answer for this last part.